and welcome back to my channel and into another vlog. So today, for my vlog, I have decided to collab with 4 other YouTubers, which are Dean, Princess, Tiffany, and Kirill to talk about limit loss and direct substitution. So it might seem like an off-topic, but we wanted to share our knowledge with the viewers. So without further ado, let's get on with the video.
So before we discuss our topic, let me first guide you to the flow of our video. So first, we have the introduction where you will learn about the limits. The second one, we have the limit loss where we are going to discuss here the limit loss and its example. And direct substitution where we are going to discuss it and also its example. And of course, we have tips that you can learn some techniques and importance of applying the loss and evaluating the limits.
What is limits? Limits is the value that a function or sequence approaches as the input or index approaches some value. Here are some examples of limits. Maybe you're wondering how to read limits. We simply read it as limits of 6 as x approaches 0. Another example, limits of 4x squared plus 4 as x approaches 2.
So what is limit loss and the different types of it? So first, limit loss. It is a properties of limits and it is used to compute the limits of a function. There are different types of limit. So first, we will be tackle about constant rule. So here's the example of constant rule. Limit 6 is equals to 6 when x is approaches to 0 because the constant function is equals to constant itself. Second, identity rule. Example of identity rule. Limit x is equals to 8 when x is approaches to 8 because this rule says that the function y is equals to x. Since y and x are equal, so whatever the value of x approaches, y will have to approach the same value. So third, sum rule. So in sum rule, the limit f of x plus g of x when x approaches to c is equals the limit of f of x when x approaches to c plus limit g of x when x approaches to c. So here is the example of sum rule. The limit f of x is equals to 9 when x approaches to c and the limit g of x is equals to negative 3 when x approaches to c. So it will be 9 plus negative 3 is equals to 6. Because this rule states that the limits of the sum of two functions is equal to the sum of their limits. Also, in sum rule, you will use the law of addition. So fourth, the difference rule. So in the difference rule, the limit f of x minus g of x when x approaches to c is equals to the limit f of x when x approaches to c minus limit g of x when x approaches to c. So here's the example of difference rule. The limit f of x is equals to 7 when x approaches to c, then the limit g of x is equals to 5 when x approaches to c. So it will be 7 minus 5 is equals to 2 because the limit of a difference is a difference of a limits. Also, you will use here the law of subtraction. Lastly, the product rule. So in product rule, the limit f of x times g of x when x approaches to c is equals to the limit f of x when x approaches to c times limit g of x when x approaches to c. Also, you will use here the law of multiplication. So here's the example of the product rule. The limit f of x is equals to 14 when x approaches to c, and then the limit g of x is equals to negative 6 when x approaches to c. So it will be 14 times negative 6 is equals to negative 64. Because this rule says that the limit of the product of a two functions is the product of a two limits. So that's it guys, I hope you learned something about limit loss and different types of limits. Bye!
Hi! For the quotient rule. So here is our formula. It is denoted as limits of f of x over g of x as x approaches c is equals to limits of f of x as x approaches c over limits of g of x as x approaches c. For example, we we have limits of f of x as x approaches c is equals to 12, while limits of g of x as x approaches c is equals to 4. Therefore, we have 12 over 4 and we will have the answer 3. And now, for the constant multiple rule. Here is the formula, and it is denoted as limits of k times f of x as x approaches c is equals to k multiplied by limits of f of x as x approaches c. For the power rule, we have limits of f of x raised to n as x approaches c is equals to limits of f of x as x approaches c raised to n. For the root rule, we have limits of square root of f of x as x approaches c is equals to square root of limits of f of x as x approaches c. Direct substitution is the substitution of the value of x to where it is needed. For example, find the limits of x squared plus 4x minus 2 as x approaches 2. So to solve this, you need to substitute the x to the given value of x, which is 2. So the given will be 2 squared plus 4 times 2 minus 2. And after the substitution, you will just going to solve it. So 2 squared plus 4 times 2 minus 2 is 4 plus 8 times 2, which is 4 is the 2 squared, and the 8 is 4 times 2, and the minus 2 is in the given. And the final answer to this problem is 10. So the limits of x squared minus 4x minus 2 as x approaches to 2 is 10.
So in my segment, I was tasked to talk about the other tips, techniques, and of course the importance of applying the limit laws and evaluating the limits. So at first, it's going to seem hard and it's going to seem difficult, but once you get the hang of it, once you study and understand, it's going to be a smooth road from there. So I will give you 3 tips and of course the one major importance of evaluating the limits. So let's start with the tips first. So the first tip is to familiarize yourself with the formulas, familiarize yourself with the laws. So I'm saying to familiarize and not memorize, because when you memorize something, there's a higher chance for you to forget it. But once you're familiar with something, once it has become a routine for you, then you're gonna have an idea right away on what to do. So when you see a limit and you're familiar with what to do, then you're going to be able to evaluate that limit easier. So the second tip would be know basic math skills. So what do I mean when I say you have to know basic math skills? This includes, of course, knowing the 4 operations, which is addition, subtraction, multiplication, and division. So you also have to know how to simplify fractions, how to simplify radicands, because in calculus that is basic knowledge, because you're going to encounter that when you're evaluating limits. So the third would be familiarize yourself, or you should know how to identify expressions and equations. So when you see a limit, you should know that, oh, this is a perfect square trinomial, oh, this is a binomial. And once you know how to identify, here comes the 4th basic skill, which is knowing how to factor. So when you know how to factor, you're going to know how to evaluate the limits and you're going to get the answer much efficiently. So the third and last tip would be analyze the problem first, or analyze the limit first. So what do I mean when I say analyze the limit first? Don't try to evaluate right away. So there will come a time where you're familiar with the limits, you're familiar with what to do, but you have understood the limit completely wrong. So then of course you're going to get the wrong answer. So analyzing it and evaluating limits doesn't have to be a rushed process. You don't have to be able to evaluate and get the value right away. So analyze the problem, know what to do. Like, should you factor it first? Should you proceed to direct substitution? Or should you do other things such as applying the limit laws once again? So now that we are done with the tips, I'm going to tell you the one key importance of evaluating limits, of direct substitution, of the limit laws, which is it is a stepping stone in calculus. So when I say stepping stone, I mean it's going to help you solve more complicated problems and topics in calculus. So in calculus, limits or evaluating the limits is known as the most basic skill because it's the easiest in calculus, whether you believe me or not, because there will come a time where you will have to deal with integrals, with derivatives, with other much more complicated aspects of calculus. And for you to be able to understand that, for you to be able to apply it to those lessons, then you're gonna have to be known into evaluating the limits. You have to know how to evaluate the limits. You have to know what are the limit laws. You have to know the basic math skills, because if you don't, then you're not going to be able to solve derivatives, integrals much more efficiently. So I will now cut this very long speech because I've been talking too much, but all I'm saying is that you have to know the value. And of course, even though it's a hard process, even though it seems complicated, you have to know how to evaluate the limits. You have to know the steps, because in the future you will be able to use it in college. Maybe not in real life, but in advanced math, you're gonna have to encounter the limits once again. So that's it. And I hope you have learned something, and I hope you will be able to apply these values into life.
And that's it. Thank you for listening, and we hope you learned something from us. Please like and subscribe!